Okay, so we're starting on, for today, we'll do reliability. And this has to do with scales or indices, okay? So some of you are using the depression scale. Some of you are using the Rosenberg self-esteem scale. Some of you are using one of the Bogardus social distance scales at the very end, right? How close do I want people who are different than me? And we have 3 different categories there. But in addition, some of you might be making your own scales. Hey, Marco. So, for example, the set of health questions, health 1, 2, 3, 4, 5, or the poly questions, the political ones, or the econ questions on the economy, or the cheat questions on cheating behaviors and thoughts. So, and there are the social ones, social 1, 2, 3, 4. So some of you may say, hey, I think those might go together in a scale. I want all the social ones, that's 4 of them. Well, if you're using each individual social item, there are 4 of them, you need to run 4 tests. So if you collapse them into one item called social activities, you have to give it a name that makes sense to you. Then that's just one thing you need to do, right? So instead of taking your time seeing if age has an effect on social 1, and age has an effect on social 2, and age has an effect on social 3, and age has an effect on social 4, that's a bit tedious, right? So if you collapse them all and call them social activities, then you can see if age has an effect on social activities, or if sex has an effect, or gender in our case on social activities, or marital status, or income, or whatever. And you get at some more interesting stuff. So some of you have already identified what scales you're using, some of you have not. The main thing to keep in mind is you cannot combine things into one scale that are on different scales to begin with. So you can't take one of the socials and one of the Bogardus social distance and one of the depressions and then weight and combine those. They're measuring different things. So when you make a scale, they have to be separate and distinct aspects of the same construct. Remember in your research question, it's very broad, you have 2 constructs, right? You might have the economy as one of your constructs. And you have to identify, how are you measuring the economy? Well, maybe you're measuring it with, have you been laid off? Are you currently employed? How much money do you make? What's your occupation? Those are all ways of measuring that construct, the economy. I'm not combining those to make one item, but how this construct, I'm measuring it using these separate and distinct items. So it's sort of like that, in that you have a construct that we call depression, and we've got 17 things that are separate and distinct aspects of depression, right? So how often do you feel it takes great effort for you to do simple things? Is 1/17 of what we call depression. Each one of these 17 items individually is not depression, but the 17 combined is depression. And this is the depression inventory that you will see time and time again. Okay? So let's get started. All right, so your learning outcomes at the end of this class, you'll be able to define reliability and validity and differentiate which is which. Define multi-dimensional constructs, so that's what we're dealing with. It says multi-dimensional constructs, these constructs that have more than one dimension. So, for example, a construct that we call age has one depression, right? What's the respondent's age? But depression has many dimensions. In this case, it has 17 dimensions that make up this one thing we call depression. And you'll be able to create an index or a scale, we'll talk about the difference between an index and a scale, and evaluate methods for dealing with missing data. So sometimes you have people who didn't answer some of the questions. What do you do? Okay? So reliability and validity. Reliability, the definition, the easy definition is if we measure it today, we measure it again tomorrow, we measure it again the next day, we measure it again the next day, we're getting the same answer. So for example, I have a scale. This little carpet tile right here is my scale. I step on the scale today and it says, you weigh 100 pounds. I step off and I go merrily about my business. I step on the scale again tomorrow and it says, you weigh 100 pounds. Step off the scale and I go merrily about my business. Is this a reliable measure? Absolutely. Okay? It's absolutely reliable because every day I step on it, it says I weigh 100 pounds. Okay. We have what we call internal consistency reliability, where several of these items are logically related to each other. This is what we have in the Rosenberg self-esteem, the DSM depression inventory, and the Bogardus social distance scales. They've been used time and time and time again in hundreds of different research studies. Okay? We know that the items, right, the 4 social distance items, the 10 Rosenberg self-esteem items, the 17 depression items, we know they're related. They have a logical relationship to each other. And the way we ascertain that is we run a correlation and we see that, okay, they vary together. As the first variable goes up, the second one is likely to also go up, but the third one goes down. The fourth one goes up, the fifth one goes down. The sixth one goes down, the seventh one goes up, or however they go. Maybe they all go up. If this one goes up, they're all going to go up. Or if this one goes down, they're all going to go down, right? Doesn't matter what it is, as long as they vary in some pattern across people. So people who tend to say, have higher scores on this number 1, also tend to have either higher or lower scores on number 2. And those people also tend to have either higher or lower scores on number 3. And as we go through, we find that. Okay, so that's what we do. Marital happiness is another example. Then we have validity. So am I measuring what I intended to measure? Let's go back to my scale. Am I measuring a true and accurate portrayal of my weight with this scale that says I weigh 100 pounds? Now, most of you can take a look at me and say, nah, I shouldn't weigh 100 pounds. Right? She weighs a little bit more than 100 pounds. Okay? So it's not a valid measure of my weight. Religious or religiosity and spirituality are a good example of this idea of validity. So we used to ask people all the time in research over the years, how religious are you? And people would answer it. And then at some point in time, people started crossing out the word religious and writing in the word spiritual and answering it. Now, first of all, if someone changes the wording of your question and then answers it, that's a missing. Right? Because they've changed your intent. Okay? They're not getting at what you intend to get at. Okay? So validity means, is it valid? Do all the people who are taking your survey or sitting in your interview or whatever, do they all understand the question in the same way? Does it all have the same meaning to them? And for a lot of people, religiosity and spirituality are very, very different. So researchers have started distinguishing between the two. And religiosity today is more likely to be measured by how often do you go to a religious service? How often do you pray to your God or gods? How often do you read your religious text? How often do you talk about your religion with other people? Those sorts of things tend to be religiosity, those behaviors. Right? And spirituality tends to be more of what you think of. You know, there's something broader in the universe than me. Whether you believe in a god or many gods or no gods, you still have the idea that there's something greater than you out there. Right? And so that's how we tend to define spirituality today. Okay? So then we have content validity, and we want to make sure we cover all parts of whatever it is we're looking at. So when you use 3 depression items and say it's depression, you do not have content validity. You're not covering all possible meanings of the construct. When you take only 4 of the Rosenberg self-esteem items and you say I'm measuring self-esteem, no, you do not have content validity because you're not covering all aspects of the construct self-esteem. So you need to make sure you're getting at all aspects of whatever it is you're looking at. Solidarity is an example. So I worked, when I was at USC, I worked on a research study and they did a lot on solidarity. So, and it was a family thing. It was all within families. So they looked at family solidarity and family family solidarity was this multidimensional construct, and there were actually 6 of them, but I thought I'd abbreviate this here. So there's affectual solidarity, so how much affection do you feel for these people in your family? Associational solidarity, how much do you see these people or associate with these people in your family? Functional solidarity, how much do you help and the people help you, right? So how much do your family members help each other? And normative solidarity, what are the norms surrounding your family and the relationships within that family? Every family has different norms, right? So then if we look at just affectual solidarity, that in and of itself is a multidimensional construct. So these are parts of the multidimensional construct we call family solidarity, but each one of these is multidimensional, so it's even more complicated. So affectual solidarity toward your son is measured by how close do you feel to your son, how much affection do you feel toward your son, how well do you get along with your son, and the person has rated each of those on a 1 to 4 scale. So if they said, not at all, how close do you feel? Not at all. How much affection do you feel? Not at all. How well do you get along with? Not at all, right? They get a point for each one of those. And if we add those up, what's their total score? How many points do they have total? Lita, go for it.
What was the question? I'm sorry.
Lita was sleeping? Oh my gosh. So if the person, I asked Lita, how close do you feel to your son? And you said, not at all, you got a point. And if I said, how much affection do you feel toward your son? And you said, not at all, you got 1 more point, right? And if I said, how well do you get along with your son? And you said, not at all, you got another point. So then I added these up, and what's your total score on your affectual solidarity towards your son, Lita? 3. So let's say Haley, I asked her the same question, and she said, very. How close do you feel? Very close. How much affection do you feel? Very much affection. How well do you get along? We get along very well. Haley, how many points do you have? 12. Okay? So this scale ranges from 3 to 12. Most people will be somewhere in between, right? Okay. Does that make sense? So, instead of having 3 individual questions that range from 1 to 4, which by the way are what level of measurement? Nominal, ordinal, interval, or ratio?
Interval.
Why is it interval?
It doesn't have a 0?
That's true, it doesn't have a 0, but that's not why it's interval. Why is it interval? The answers run from not at all to very. It's a Likert exception. It's ordinal, right? Not at all to very, that's ordinal. Okay? But it's probably a Likert exception because there's some sort of a neutral that's implied in there somewhere. And then we've got extremes. So not at all and very are the extremes. Okay? They're the mirror of each other. So it's truly ordinal, but we're going to use it as interval, as Ali said, because it's a Likert exception. Okay? So my life is way simplified if I have one variable called affectual solidarity towards son that I can run tests on, rather than running repeated tests on 3 individual variables. Okay? So that's the whole point of it. About that. Okay, so here are some other samples. So HIV risky behavior is my construct. It's measured by asking people in my survey, have you ever used IV drugs, yes or no? Have you ever had sex with a bisexual or homosexual man, yes or no? Have you ever given money or drugs for sex, yes or no? Have you ever taken money or drugs for sex, yes or no? Now, for a person who answers no to all of these, what's that person's score? 0. For a person who says yes to all of these, what's that person's score? What?
4, right?
4. Okay? So this one ranges from 0 to 4. Probably a lot of people have 1s or 2s or 3s, right? Some people have 0, some people have 4. Some people have 4s. Okay? What level of measurement are these original variables? Just these. They're nominal, and are they special? They're what? Are they Likert? Yes, no? A nominal variable can't be Likert. So, but what's special about them? They're dichotomous. So that makes it really good for us because we can run more tests with dichotomous variables than we can with these categorical, like married, separated, divorced, widowed, right? Okay, so dichotomous makes it special. We only have two special things, dichotomous or Likert exception. It's better than the English language. There are only two specials, right? Now, once I've combined it and it ranges from 0 to 4, now what level of measurement is it? Chloe? Ranges from 0 to 4. People can score a 0, a 1, a 2, a 3, or a 4. It's that nominal ratio. Why?
0.
And that 0 implies the absence of whatever we're measuring, right? And we're measuring HIV risky behavior. And if you said no to all of these, you're not engaging in risky behavior, HIV risky behavior, so you have the absence of that. So that's why it's ratio. Okay. All right. Indices and scales. So indices and scales allow us to measure several dimensions with a single value. If you haven't already gotten that, that gives you that concrete. And they're composite measures, and you can only create them from variables that are dichotomous or continuous. So what's the only kind of variable you cannot do this with? The only kind of variable you cannot create a scalar index with. What variable is not mentioned there? When I say continuous, what do I mean?
So you can't do it with something that's just one variable?
Well, they're all one variable that we're combining, right? They're all one individual variable, but each individual variable has to be dichotomous or continuous. Nominal, ordinal, interval, or ratio. Now, Nick, can you see that, or is the screen in order? Okay. So nominal, ordinal, interval, or ratio. Okay. The answers to a variable that's nominal or ordinal are what? What kinds of answers are they?
Yes, no.
Okay, they could be yes, no.
Categorical.
They're categories. The answers are words, phrases, or ranges of numbers. Okay? So 1 to 3, 4 to 6, 5 to 9, right? Ranges of numbers. That makes them categorical. Okay? The answers to interval or ratio level questions are what? They're numbers. They're always numbers. They're a discrete number. One number, not a range of numbers. So 9. This person had 6. Okay? So discrete numbers, one individual number. Okay? Now, these ordinal, interval, and ratio are also called what? Okay. Interval and ratio are also called what, Allie? Scale. Ordinal, interval, and ratio are also called, you have this in your notes like at least 3 times. And I told you the first time I did it, you're going to see this time and time again. So this should look very familiar. Continuous. Okay? Continuous. So, what kinds of variables? If I have dichotomous or continuous variables are Haley, come on, you just said it. What kinds of variables are continuous? Ordinal, interval, or ratio. So I can use ordinal, interval, or ratio level variables. But I can also use dichotomous level variables. So what are dichotomous level variables? N. So these could be dichotomous or what's the other thing these could be? Say that louder, whoever. No, it can't be continuous, because there's no order to them, right? So they can't be continuous on a continuum. But if they're not dichotomous, if they're not two choices, what are they? If they're not two choices, there must be. Think of a nominal variable on our survey. What's one of the nominal variables on our survey? Look in the demographics section. We have gender. How many categories are there on our gender? There's at least 3, right? But I think we're up to like 5 or 6. But there's at least 3. So 3 plus. So nominal variables can be dichotomous, 2 only, or 3 or more. And those 3, they're both categorical, but we tend to call these dichotomous and categorical, just to distinguish. So now, what kind of variable is the only kind of variable I cannot use, I cannot create a scale with?
Nominal level that aren't dichotomous.
Exactly. So something that has 3 or more categories. So, gender on our survey, marital status, okay? So anything that's nominal level and is not dichotomous, you cannot do this with. And that's really important, because the computer doesn't know that you're putting garbage in, right? You have to know what you're putting in. Okay? Garbage in, garbage out, but you have to be able to know that you're putting garbage in if you're trying to put in a variable that doesn't work. Okay? So only dichotomous or continuous. All right, so an index is what we do when you take an exam for most classes, right? I'm asking for your knowledge of U.S. history from 1860 to 1750, right? That's my construct that I'm measuring, and I'm going to give you this 100-point multiple choice test. And I'm going to ask you individual questions that are getting at those individual little dimensions of U.S. history from this year to that year. And all 100 together are measuring that construct, your knowledge of U.S. history from this year to that year. Okay? So merely, I just literally take each right answer, and that's a point, and I add up all those points, and that's your score at the very end. Okay? So you're very familiar with that, right? We do the same thing with IQ. We give you a bunch of little tasks, and we add up your score, and we give you an IQ. Do it with a lot of different things. So that's technically called an index. Okay? Now, scales are a little bit different. Scales measure intensity, but we tend to use those words interchangeably. In fact, the Rosenberg Self-Esteem Scale is actually an index, but look, it has scale right in the title. So scales and indices, we're tending to use those words interchangeably today. Levy, you okay? You want me to go back? Okay, I can go back. Yeah. Holler at me. And it's okay for you to speak, because if you want to be off the tape, I can cut you out, right? So don't worry about that. So it's all right to participate. And if you want to be on camera, come on up and dance in front of the screen.
I'm so down.
Come on.
I'll do the Macarena.
Good.
While Rita's finishing.
Alright. Jesus. Alright.
It's logical.
Right.
It goes. What?
It's bright.
It is bright.
Okay, we're moving on, Ollie. Someone sing the song for him.
Hey, Macarena.
Yay! Maybe that'll be an outtake.
Do it.
I'll publish that on YouTube.
The highlight.
Okay, the highlight reel, yeah. Okay, so to create an index or scale, you're going to select all the items that seem to fit. Now remember, you have this lot, they logically fit together. So in your brain, these have to go together. You have to be able to say to yourself, these 5 things are different aspects of this broader construct. And I'm going to call this broader construct X. And the name you give it, X, has to make sense. Okay? It can't be some craziness. It has to make sense. Okay? So they have to be related. Again, the answer to one item is correlated with the answers to your other items. So they have to vary together. As people tend to score higher on this one, they tend to score this way on this one, and this one, and this one, and this one. Good? All right, so the first thing we do is we run, oh, by the way, you can warm up your computers. The first thing we do is we run a reliability analysis. Okay? Or, no, the first thing we do is we run that bivariate correlation, but this is on the route. So we run the bivariate correlation on all the items. Now remember, a correlation is bivariate. It's just looking at this variable and that variable together. But you put in all the variables that you want. And remember, we looked at extreme cases pairwise and listwise. Remember that? And the default is pairwise. So if someone did not answer both of these questions that are being correlated, they're thrown out of the run for that particular pair. But if we select listwise, it says you have to have answered, the respondents have to have answered all 5 of these questions in order to stay in the row. Okay, so remember that? We'll go over that again. So you're looking for them to be correlated at about a 0.4 or greater. Now sometimes what you'll find is, well, this one's correlated at a 0.6 with these 3, but only at a 0.2 with this one. But this one's correlated at a 0.4 with that one, and this one's right? So sometimes you're not going to get all of those 0.4s on all of the correlations. It's still okay to go to the next step, because the next step is the most important one. But if you run this bivariate correlation and none of them are correlated at a 0.4, you don't have any 0.4s, they're all lower, move on, right? So then you go to the second step where you run this test called the Cronbach's alpha. And the Cronbach's alpha is like a giant correlation, but it's looking at it in a multivariate way. It's looking at, as this one goes up, what tends to happen to this one, this one, this one, and this one. And it gives you sort of like a grand correlation. It's called the alpha. And the alpha needs to be 0.7 or greater. So that's your goal, is to have an alpha of 0.7 or greater. If you have a 0.69, yeah, you know, go for it. But if you have a 0.5, no, probably not so good. So this is a pretty loose suggestion. This is a pretty firm suggestion. Okay? You want that 0.7 or greater. And it's just like a correlation in that the highest score you're ever going to get is a 0.999. Right? Because 0.1, 0.0 is a perfect correlation. You're never going to get that. Right? So it's always going to be a decimal point. 0.999 is the highest. 0.7 is, that's where you shoot. We're good? All right, so.
Sorry.
It's okay.
Okay.
Okay. So here's a correlation, right? We look for the ones, we draw a line, we scratch out 1/2. It doesn't matter which half since they're a mirror image. And we see that unemployed and looking for work a month or more is correlated with being demoted or moved to a worse position. It's correlated at a 0.9. Unemployed and looking for work is correlated at a 0.9 with cut in pay or reduced hours, and unemployed looking for work is being passed over. Okay, and then being demoted and cut in pay, being excuse me, I'm being passed over, and then cut and pay passed over. Okay? So they're all correlated pretty high, right? They're all 0.9s. So we run that first, and then we go ahead and we run the Cronbach's alpha, and we get this little box first. It's called reliability statistics, and it tells you the Cronbach's alpha and the number of items. So I put 9 items in, I ran it, and I got an alpha of 0.908. It's higher than a 0.7, so I'm rocking. I'm good. Okay? Then this is the rest of the printout. So the printout is this followed by this. This is the rest of the printout. And we only care about this last column. That's the only column we care about. It lists all 9 of my items. And then it gives me the Cronbach's alpha if item deleted. So what it's saying, Haley, join us please, is that if I delete this item, my Cronbach's alpha, 0.908, will go up to 0.990. But instead, if I delete this item, my Cronbach's alpha of 908 will go down to 905. Okay? So you're always trying to make it higher. You certainly don't want to go down to 729, right? Why would I lose own business losing money or failing? Right? Why would I want to get rid of that and have it go down? The only way you want it to go is up. Okay? Now it can go up, but 908 to 0.990, do I want to lose that item to make it go up that amount? It's going up less than 0.9, right? It's going up 0.88. 0.088, right? It's going up 0.088, so it's not going up a whole lot. But if I look back at these and I say, yeah, I think that doesn't seem to cover the same thing that all of these cover, then I would want to get rid of that, rerun it, and when I rerun it, this will say 0.990 and this will say 8, right? Because I got rid of that variable, unemployed and looking for work. Does that make sense? Okay. So if you take a look on your next page, which is 60, copy the path diagram. And it says Cronbach's alpha reliability analysis 11 items. So this is what the full printout looks like. Get this little case processing summary. We don't care about that. We only care about 2 things. The Cronbach's alpha, which is what in this particular one on page 60? 0.942. How many items are there? 11. And if I counted them all up, I'd see 11. So you displayed affection, you were angry, that's been recoded. You calmly discussed something, you had conflict, that's been recoded. So we've got these 11 items. 942 is what it's at. That's certainly quite respectable, right? 0.9 is a very strong alpha. Can I make it higher as I look at the column that says Cronbach's alpha if item deleted? Can I make it any higher than that? Yes or no? Can I get that 942 up any higher?
Yeah.
Right? Yes? Katie, which one would I have to delete to do that?
Let me see, I'm kind of blank. I'm sarcastic or?
You sarcastic. You. That's like Y-O-U, right?
Close.
You sarcastic. You were sarcastic to each other. This is the marital satisfaction stuff. You were sarcastic to each other. And what will it increase it to? 0.948. So, to go from 942 to 948, how much am I increasing? .006. Not a lot. But I want to take a look at these. Okay, so does that you being sarcastic to each other, does that fit? Well, it's part of the accepted Gilford-Bengtson marital satisfaction scale, so I would definitely keep it. But if you were creating your own scale, not using an established scale, you would look and you would go, well, maybe sarcastic doesn't fit. Or, yes, it does, I'm keeping it. I don't need to go up anymore. As long as you're at a 0.7, you're good, right? Now, If you have something that jumps you from a 0.7 to a 0.9, take a really good hard look at that. Because the computer's saying, this doesn't go together so well as the others, right? So if you turn to the next page, I've actually rerun it so that you can see, and you see use sarcastic is missing from below, and up above on the reliability statistics box, it says 0.948, and it says now I only have 10 items. Okay? Make sense? We good? Let's talk a little bit about missing data, and then we're going to go to SPSS. So, there are a variety of things you can do with missing data. The computer, if someone's missing on a particular variable, it just excludes them, right? It's missing. Okay, moving on, right? I just don't use that. So you can do that. That's the most common thing. Maybe you've decided that missing is valid. Maybe you see that there's a whole series of people who haven't answered something, and they have some characteristic in common. And that might be in and of itself really interesting to you. So what we know is that we tend to get a lot of missing data on income for, which income group of people do you think?
Like the two most ones.
No, it's the highest. So wealthy people don't like to tell their income. Okay? So that's something interesting that people discovered as they were doing research and saw lots of missing data, and they had other measures of how much money these people might have, right? You can, let's say you have a variable, and you have 3 people who are missing on that variable, but you don't have a whole lot of data, so you really need to recover those 3 cases, right? So you can assign the median if it's skewed, or the mean if it's not, of the other respondents. So you get the median or the mean score, you decide is it skewed or not, and then you plug in the value to those 3 people who are missing. Okay, people do that. You can assign random values. You can flip a coin if it's a yes, no, or a dichotomous. If there's 6 choices, you could roll 1 die, right? You can pull numbers out of a hat. You can use a list of random numbers, which you'll learn about in Soci 132 if you can take that. So you can do that. Or you can do what we call impute, and this is only if you're creating scales. So let's say you have the 4 of the Bogardus social distance variables, okay? You have Bogardus social distance 1, 2, 3, and 4, and you see that a particular respondent didn't answer one of those questions, but that person answered the other 3. So you can, what we call impute, you can take that person's mean score on the other 3 and plug it into their 1 missing. Now you have to have a minority of them missing, right? So if you had depression, there were 17 and they were missing 2 or 3, you could impute their mean score on the others into those 2 or 3. But on Bogardus social distance, where there are only 4 of them, in the case of our study, there are only 4, you can't be missing 2 or 3, right? You can only be missing 1, or it's just not a valid way to do it. So those are the different things that you can do with missing data. Okay, any questions? All right, so let's go to SPSS. So Mr. Mariano's not here, and John McKenna. We are going to use file 4. Get it from the Z drive. In this room, we had a lovely Z drive short. Really nice. What I could get that a couple years ago when we first asked them. All right. Bye. Okay, have a good day. So everybody's got this. Look at your family members, and you see that they all have practice file 4, SPSS 4. Good, anybody not here? Y'all have 4? Yeah?
No.
No? Help your family members. Omar, how you doing? You got 2 ladies helping you.
Almost there.
Okay.
Yeah.
So help your family members, make sure everybody's there. We're good? We're good? Okay. How we doing there? Good here? And your poor family's down to 2 people. All right. Okay. Chloe, are we good in your family yet? Okay. Did we get there? And then your family's good? All right, so here we are, we've got this practice file 4. We are going to do these variables that are called health. See them here, health 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Okay, so we're going to go to analyze, scale, because we're making a scale, right? Go to scale, and then we'll go to reliability analysis, and then click on that. And we get this little reliability analysis dialog box. And we want the health items, so we can click them over, we can double click them, we can click once and push the arrow, we can click on the first one, then hold the shift key down and click on the last one and then push the arrow, but however you get them over, do all 9 of them. Okay, once you get all 9 of them over, we're going to click on the statistics over here on the top right. And we want scale if item deleted. We always have to ask for scale if item deleted, or else it's just going to give us those top 2 little boxes. And then click continue and click OK, and that's all we need to do. And we have our Chromebook Excel file. So we have the case processing summary again. We wrote here. There were 953. Oh, I forgot to do the correlation first. There were 953 of them, and there were 497 valid answers. Sorry, 953 valid answers, 497 not valid. Let's go back a step because I forgot. So you're going to do analyze, correlate, bivariate, and get these 9 health items over. And then click OK. And we got our correlation. So this is step 1. I'm so sorry. Okay. So remember, we've got the ones. We only need to look at half of it. Works the same way in Word if you want to select a series of text. Put your cursor at the first place, hold Shift, and then click at the last place, and it'll select that whole series. Okay, so what kinds of R's do we have? You can look on mine, you can look on yours. What kinds of R's do we have? We have high enough R's? What's the R for counseling for mental problems correlated with ill enough to go to a doctor? .093. Is that a .4 or greater? No. Okay? So if you look at all of them, I mean, you just look through, do you see any .4s or greater? Okay, so I would say move on, right? But we're going to go that second step and we're going to run that reliability analysis. So if you scroll back up, you can see the reliability analysis. And you can see that the Chromebox Alpha is what? 0.245. Is that high enough? No. Can I make it any higher? What's going to happen to it if I delete ill enough to go to a doctor? It's going to go down to 0.201. Can I make that 245 any higher?
Yes.
What do I have to delete?
Barbarian Hospital.
Yep. And then it will go up to 0.256. Is that going to help me? No. I'm never gonna get this up to 0.7. I could delete it, run it again, see if another one will make it higher, delete it, run it again, see, right? You have to have at least 3 items, so you can't delete it, keep deleting and deleting until you're done, okay? So, not super helpful, right? So let's take a look, let's run this again. We're going to run a correlation, we're gonna do it in the right order this time. Bivariate. I can either highlight those and push them back over, or I can push the reset button. And that's supposed to push them back over. Why? Oh, there it goes. Okay. Push the reset button, and then when I click on it, they go back over. And the variables that I want are complement. And mine's not in alphabetical order. Complement. Help home. Hobby. President. And relationship. Okay? Complement, help home, hobby, president, and relationship. Those are in alphabetical order. I think all of your lists are in alphabetical order, right? Your list on the left, it's in alphabetical order, yes? Okay, so the whole room. So right click and say sort alphabetically. Makes your life way easier. I thought they had fixed it. That was just my computer. Oh shoot, I just hit reset. Correlate, bivariate. Let me go back and get them again. Complement, help home, hobby, president, relationship. Okay, so do you have those 5 over there? Once you have those 5, click OK. My house is so sticky. Okay, and I have correlations. Now, how are these correlated? Well, this one, I have a 0.0, a 0.7, a 0.0. This one I have a 0.0, a 0.9, a 0.0. This one I have a 0.0, 0.0, and this one I have a 0.9. So they're all sort of, they all have a high one somewhere. Okay? So I'm going to give it a try. I'm going to see what it looks like. So I'm going to go back to Analyze, Scale, Reliability Analysis, and I'm going to reset this guy. And I'm going to go back, I'm going to right click and say sort alphabetically because they picked it. And I want complement, help home, and you hold down the control, you can click on this. Hobby, president, relationship. So the shift gets a continuous set, but the control gets individual ones. Okay? So I'm going to say, click those over, say OK. Oh, I forgot to say, because I reset it. Statistics, scale if item deleted. Okay. Okay. All right, so I get this. So my alpha is 0.700. I have 5 items. Is that an acceptable amount? Is that an acceptable alpha? Everybody with me? Is that an acceptable alpha? Is that 0.7? Katie's very, very, very slightly nodding her head.
I'm just really putting up there.
Okay. That's acceptable. 0.7. I told you it needed to be 0.7 or greater. That's acceptable. Okay, can I make it any higher?
Yeah.
Okay. What would I have to get rid of to make it higher?
Hobbies.
What?
Hobbies.
Get rid of hobbies. Agree that you do hobbies with your spouse. Okay? Now, if I look at these, agree that you and your spouse complement each other. Agree that men should help at home. Agree that you do hobbies with your spouse. Agree that a woman is capable of being president. And agree that women can initiate a relationship with men. Okay? What am I measuring here? Do they all seem to fit together? Or do I seem to have a couple of different things here? What do you guys think? The woman as president is different. Where's president? But if I get rid of that, it goes down. Is this about you and your relationship with your spouse, or is this about global something about women and men? What about this one? What about this one? Personal. What about this one? What about this one? So we have 3 that lead us as are global and 2 that lead us as are personal. I absolutely agree with you, right? And I bet that you all do. So let's go ahead and let's delete that one to see if we can get that 733. So that's hobby. So we're going to go back to analyze, scale, reliability, and we're just going to take hobby and we're going to pop it back over to the other side. Okay? And then we say okay because everything is still set. And it goes up to 733, which again is perfectly respectable. Can I make it higher? Check it out. What do I have to delete to make it higher, and what will it be?
Agree you and your spouse combination there, and I'll be a
It'll be 0.965, so it's going to jump way up, right? And we've already decided that that makes sense to get rid of that one. Okay? So let's go ahead and do that, just to prove to ourselves what happens. Go back to analyze, scale, reliability, and get rid of, that was complement. No, that was, yeah, that was called complement, right? Rid of complement, run it again, and look, I get a 9.965. That's great. That's a really strong correlation. Can I make it any higher? No. And for 2 reasons. Because there's no number that's higher, but also I only have 3. You have to have a minimum of 3. So even if I could make it higher, I can't make it higher because I have to have a minimum of 3. I can't have 2. Okay? So now I've got this. Now I'm going to make this variable. I didn't do anything to it. I'm just checking it to see if it fits. Now that I know exactly what fits, I know that I want to take these 3 variables and make them into the one. And these are president, help home, right? Help home, president, and relationship, right? So I'm going to take those 3 and make a new variable. So I'm going to say transform, compute. We've been here before. Does anybody remember when we went to transform and compute? When did we do that? Anybody remember? Does it look at all familiar? Okay. We did this when we were jittering variables. Remember we went to the function group, and we went to the random numbers function group, and then we went to the RV uniform. Where's it down here? RV uniform. Remember that? And we put in 0.5, negative 0.5, and positive 0.5. Okay? We're not going to do that. We don't need to do that. We're just going to make a new variable. So our new variable, what are we going to call this variable? What is the name of this construct? That women can be president. Women can initiate relationships, and men should help at home. What's that construct? Come on, sociologists. Non-sociologists, you can have a pass, but those of you who are sociologists, if you've taken more than one sociology class, especially if you take an intro or women's studies or sexuality, gender role ideology, right? This is people's ideas, this complex of ideas about appropriate gender role behavior for men and women. Okay? So let's call it gender role ideology, which I like to abbreviate GRI. I don't want to type out that whole long thing. But I'm going to put in a label just so that the printout is nice. So, gender role ideology. Okay, and continue. Alright, and so I'm going to take president, help home, whichever one I want. I can right click to sort alphabetically again. And I can take relationship, because I have to be right there. Plus president plus help home. Okay? So it's a backwards math problem. And it says, first person, score on relationship, plus that first person's score on president, plus that first person's score on help home. Add those up and it equals their score on GRI. Now do that for the second person, third person, fourth person, fifth person, right? And that's all I'm doing. I don't need any function groups. I'm not doing any of this business. I'm just saying score on each of these three, add them up, and it's going to be their score on this new one. Everybody with me? Check your family. We're good? And then just say OK. And at the bottom it says I've computed this new variable. If I go down to my taskbar and I go back to my data set, scroll all the way to the right, you can see I have a new variable called GRI. And you can see that help, home, president, and relationship are right next to it. A compliment and hobby are a little farther to the left. And you can see that these range from 1 to, each individual help, home, president, relationship ranges from 1 to 4. Did someone say 4? Okay, 1 to 4. See there's a 4 right there? You can look and you can see, if you go to descriptive frequencies, you can put in help, home, president, relationship. Help, home. I lost it. Oh, there it is. Help, home. And also put in our new GRI. Okay? Then go to statistics and click on mean and median. Click continue and click OK. Everybody with me? Check your family members. So I've got a frequency with president, relationship, health, home, and the new gender role ideology variable. And I've gone into statistics and checked mean and median. Click OK. I can see that each of these range from 1 to 4. Oh, actually, I think they range from 1 to 5. Because I think strongly agreed would be number 5, but no one strongly agreed. Okay? So we can check it in here. If we go back to the data set, to the variable view, and we look at one of these, we can see they range from 1 to 5. See that? So 1 is strongly disagree and 5 is strongly agree. At the bottom of the page. Okay, so I'm going back to my output. So if these range from 1 to 5, what's my minimum score on gender role ideology? What's my minimum possible score on gender role ideology? Well, these range from 1 to 5. What have I done on gender role ideology? I've added these up. So if you, Annette, had a 1 here, a 1 here, and a 1 here, what's your score? 3. Okay, let's say that Andrew had a 5 here, a 5 here, and a 5 here. What's his score in gender role ideology? 15. Okay? So if the minimum possible is 1, the maximum possible is 15. So if we scroll down, we can see that nobody's score, the minimum is 3, the maximum is 15. People did score 3s. No one scored as high as 15. But the scale still ranges from 3 to 15. Okay? So I can see these 1,450 people, what they scored. Now I can go back up here to the little statistics box to decide, am I going to report the mean or the median, right? I don't care about these. I only care about this, right? Because now that I've made this new variable, this is the only thing I care about. So I can see that the mean is 7.15 and the median is 9. What's the difference? What's the difference between 7.15 and 9? 9 minus 7.15. 1.85. 1.85. So the difference between the median and the mean is 1.85. Now let's look. We have scores of 3 to 12. What's that range? 12 minus 3 equals 9. Okay? So we have a range in the actual scores. The scale can go from 3 to 15. But we have a range in the actual scores of 9 points. Is this 1.85 difference a lot or a little within the context of a range of 9? It's a little. It's not quite 2/9. That doesn't seem like a whole lot to me. So since we're saying it's a little, do I report the mean or the median? If I'm saying it's a little, is it skewed or not skewed? Not skewed. So if it's not skewed, what do we report? The mean or the median? The mean. Okay? We want to use the highest measure of central tendency, the most sophisticated measure of central tendency, which is the mean. Right? It's the mode, the median, the mean. The most sophisticated measure, unless it's skewed, that's when we report the mean. Alright? That's really important, you guys. It's a very important concept. Okay? So, we're going to say, I created a gender role ideology scale. By combining how much respondents agree that a woman is capable of being president, comma, how much respondents agree that a woman can initiate a relationship with men, comma, and how much respondents agree that men should help out at home. The alpha was, I forgot, 0.9 something or other. The alpha was 0.965. The mean was 7.15. The mean score was 7.15. And the scale ranges from 3 to 15. Okay? So you have to say that. You have to talk about how you made your scale. Same thing with depression. I created a depression scale of the 17 depression items. Now, with 17, you're not going to list them all. You probably list a couple of them. For example, how often do you feel fatigued? Or how often do you feel sad, blue, or lonely? Right? Same thing with Rosenberg self-esteem. I created a self-esteem scale with the 10 Rosenberg self-esteem items. For example, give an item an example of a positive and a negative or something like that. Right? Same thing with any scale, cheating, whatever. Okay, now let's take any questions. Let's take a look back at the code book on the Rosenberg, and that is 23, page 23. And the page starts with questions about your health, exercise hours, and right after exercise hours on the code book, not on the survey, but on the code book, it says, these are the Rosen self-esteem items. The 5 negatively worded items need to be reverse coded before creating the scale. So which are the 5 negative items? Anybody? Which 5 of those are negatively worded? So that if you strongly agreed, it would be like low self-esteem.
Wouldn't it be
Katie?
3, 5, 8, 9, and
3,
10?
5, 8, 9, and 10. Does anybody not agree with that? Does anybody not see how those are negative? So one is, I'm a person of worth, at least I need to complain of others. Right? That's sort of positive. Strongly agree means I feel good, right? But 3 is, all in all, I'm inclined to feel I'm a failure. So strongly agree means I don't feel so good about myself. Okay? So you have to reverse code those. Those are the first thing you do. So we're going to go do that. We're going to practice that. That's the only one you have to do. So I'm going to go back to transform. We're going to recode into a different variable. Not you can go get the data set. We're going to go to a different variable. Now, we don't have self-esteem on this particular data set, so let's just do it with a couple of the health items. Let's say health 1 and 3, let's say that they're negatively worded and all the other health items are positively worded. Okay? So, you know what, it doesn't matter, let's not do that. Let's open up the actual class data set. So go back to the Z drive, get the class data set. Thank you. Is everybody frozen like me? Or are you guys good? Okay, get the class data set. Now it's good. Oh, I know why. You have to get out of the outlook. You don't want to be in the outlook. We're going to be in the data set. And then say open. Hi, Marco. And go to the Z drive. 137 and then class data set. Fall 16 data set. Okay. Has everybody got the class data set? Yeah? Good? Okay. Alright, so we're going to go transform, recode into different variable, and we're going to get the Rosens, and if you right-click, you can sort it alphabetically, you can find the Rosens. And we want Rosen 3, 5, 7, 8, 9. So 3, 5, 7, 8, and 9. What? I'm sorry?
8, 9, 10.
Oh, thank you. 3, 5, 8, 9, and 10. You hate that. I would have really messed it up. 3, 5, 8, 9, and 10. Click them all over. Okay? Now I have to go individually to name these. So I'm going to call it the exact name, Rosen 9 underscore and a capital R, and click change. I'm going to click on the next one, Rosen 8 underscore capital R and change. Rosen 5 underscore capital R and change. Rosen 3 underscore capital R and change. And Rosen 10 underscore capital R and change. Okay? And so what this is saying is my variable that I'm taking in is Rosen 10. My output variable is going to be Rosen 10 underscore R. Okay? And R just is typical, that underscore R is for, okay, this has been recoded. Okay? I can do them all at once. I don't have to do them one at a time. So then I go into old and new values, right? We went here before, old and new values. And remember I have all these values on the left and values on the right. So I want to recode, I want to reverse code them, and it ranges from 1 to 4. So a 1 on these is going to become a 4. A 2 on these is going to become a 3. A 3 on these is going to become a 2. And a 4 on these is going to become a 1. Okay? And that's all I care about. Missing stays missing. Okay? Does that make sense? So on the old variable, these 1, 2, 3, 4s become 4, 3, 2, 1s on the new variable. Just for these 5 items that I put in. Okay? So once I've done that, I'm going to say OK. And I'm going to say OK again. And it's going to run it. And then it will tell me what it did here. Right? Let's run them all in there. Where are you? Are you with me? Yes or no?
I'm catching up.
Okay. You got to holler. I don't know.
No,
if
I
you're-
know.
Can you go back to the old and new?
Yeah. So if I go back to the transform into different variables, old and new values.
How did you get the 1?
I'm just using these values, so I'm typing in a 1, becomes a 4. And then I click add, and it gets into my list. Okay? Good? And then you say continue, and then you say OK. And then you get this little thing saying you ran this, and then go to the data set. And make sure you go to the right data set, right? Because I saw that one open. Go to the data set, scroll all the way to the right, and you have 5 new items. Okay? Now I want to see if they go together, right? So what's the first thing I do? I'm going to run a correlation first just to visually inspect it. So analyze, correlate bivariate. And I need to get those recoded ones. Now my file's in order, so they're all down at the bottom. So I get those 5 recoded ones. And then I'm going to find the other roses that I did not recode. So I want rosin 1, and rosin 2, rosin 4, rosin 6, and rosin 7. So when I look at my list, I have rosin 1, 2, 3 recoded, 4, 5 recoded, 6, 7, 8, 9 recoded, 10 recoded, right? So I have 10 of them. And they're all 10 different ones, right? Does that make sense? Okay? And so then I say, okay, and I look, they're 0.4s, 0.5s, they're a couple 0.2s, a 0.399, but they're looking, okay, I got a lot of 0.4s in there. So now I need to run my alpha. Is everybody with me? Okay. Karina and Omar, what's going on back there?
Nothing.
Are you lost or are you just having so much fun?
So much fun in this.
Okay. Don't get lost because you guys have to do this, right? Be on your homework. Okay, so now I'm going to say scale, reliability. I'm going to find those same 10 items. So I want the 5 recoded ones and the 5 others, which is rosin 1, rosin 2, rosin 4, rosin 6, rosin 7. So I've got all 10 of them. And I'm going to say, oops, sorry, I'm going to say scale if item deleted in the statistics. I say okay and okay. All right. I have my 10 items. Have an alpha of 0.858. Can I make it any higher? Make it any higher? So can I make it any higher? It's 858. If I look at this column, can I make it any higher? Katie, out loud. No. Okay, no. None of these, if I get rid of any of these, none of these will make it any higher. This is the accepted self-esteem scale. I wouldn't want to, even if it got a little bit higher, I wouldn't want to lose one. This is the accepted scale. The depression, the Rosenberg self-esteem, and the Bogardus social distance. Okay. So, in my project, I will say, I created the Rosenberg self-esteem scale. First, I had to recode 5 negatively worded items. I might give an example of a negative and a positive. Then I ran the Cronbach's alpha, or you didn't have to say that, but my alpha was 0.858 on these 10 items. Then I'm going to create them. I'm going to add them all up with that compute, right? Remember compute. I'm going to add them all up, all 10 of these, the recoded 5 and the regular positive 5. Add them all up. I'm going to figure out my scale ranges from, it's going to range from 10 to 40, because each one is 1 to 4, and there are 10 of them, right? Scale ranges from 10 to 40, and the mean, or median if it's skewed, score is this. Okay? What questions do you guys have? Does anybody need to see anything again? No? You guys are so quiet. think only 5 of them. Econ ones are a little bit, they're different types of things. Okay? So you need to go through this process. The only one you need to do any recoding for is this one, the 5 Rosenberg-Sunstein negative items. It's the only one you need to recode. That's why that takes place. Okay? So if there's no questions, work on your homework. Okay? And then we'll start on regressions next week. And you'll finish up regressions with pre-doc.